Today we're going to talk about the unit circle. And the unit circle is very simple. It's a circle whose radius is 1. So notice that we have here a circle on the coordinate plane. The center is right there. And notice that each radius is 1. So this point here is 1, 0, 0, 1 up there, -1, 0, and finally 0, -1. If we think about angles in this circle, we notice we're at 0 degrees at the beginning, and up at the top we're at 90 degrees, where we have pi over 2. We could write 90 degrees. If the angle were to rotate all the way to meet itself again at the diameter, we'd be at pi radians, or 180 degrees. And then, of course, we would be down at the bottom at 270 degrees, or 3 pi over 2, and then coming all the way around again. So no matter what, no matter what angle we have, the radius will always be 1. So if I just draw one angle here, let's say, and we'll call that angle theta. So let's do that. So that's angle theta in here. It's just a Greek letter. This angle here ends at that point, and notice that this radius is still 1. And of course we could rotate that if we wanted to, rotate it to any of the other quadrants, and we would still have the radius equal 1, and it would just be a different degree angle. So now let's go to the next screen. And let's once again draw an angle in the circle, like that. And we'll call that angle theta again. And we're going to drop a perpendicular so we can form a triangle. And if we want to get the coordinates of the point on the circle, we have to think about what we have here. Notice that the distance from the center to the drop perpendicular would be our x. So we'll put x over here. And the vertical distance would be y. And that would be our y coordinate. Keep in mind, once again, that the radius is 1. Now, if I wanted to find the sine of angle theta, which we'll put over here on the right side, if we want to write the sine of angle theta, we know the sine is opposite over hypotenuse. If you've forgotten that, we can remind ourselves of our mnemonic for our trig ratios. So, ka toa, where sine is opposite of hypotenuse, cosine is adjacent of hypotenuse, and tangent is opposite over adjacent. And so sine is opposite over hypotenuse. Therefore, it would be the y value, which is opposite the angle theta, over the hypotenuse, which is 1. So the sine of theta is equal to y. And also, if we notice the cosine of theta is equal to adjacent over hypotenuse, and that would be our x over 1, which is x. Well, this is a very interesting result, because if we look at that, we notice that our x value is really just the cosine of theta in a unit circle. So instead of writing x comma y, we could certainly, and we could say, well, if x is really just the cosine of y, we could say this coordinate is the cosine of theta, and for x, and y is the sine of theta. So this point right here, yes, it's xy, but it's really cosine of theta and sine of theta. Well, that makes for a very interesting unit circle, which is why we picked the unit circle, because now we know that the x coordinate is cosine of theta and the y coordinate is the sine of theta. So let's write this a little bit more neatly so you can see what we have here is the unit circle. And this point right here is our x comma y. but it can also be written as the cosine of theta, sine of theta. So let's do a little example. So let's draw a 60-degree angle, and we'll estimate that to about here. Okay, and we'll say that's 60 degrees. And let's drop our perpendicular. And we'll indicate that's a right angle. Let's move that back over. And we know that from our special triangles that the cosine of 60 degrees is a half. And since we have determined in our unit circle that the x value is always the cosine of the angle, let's just write that again, cosine of 60. And we know that the cosine of 60 is a half. We're just going to put 0.5 right in there. And we know that the y value is the sine of 60. And we have learned previously that in our special right triangle, which is a 30, 60, 90 right triangle, that the sine of 60 is the square root of 3 over 2. We could put the square root of 3 over 2 here. Keep in mind, this is a 30, 60, 90 right triangle, because if one angle is 60, one angle is 90, then the other one has to be 30. So notice what we have here. We have a unit circle. We put a 60-degree central angle there, and we immediately know, because the x value is the cosine of the angle, in this case 60, that the x-coordinate is 0.5, and because the y-coordinate is the sine of 60, it must be the square root of 3 over 2, and we now have the coordinates of that point right there. Okay, so now it's your turn. What we want you to do is find the values of x and y on this unit circle, given that this angle here is 30 degrees. Find those coordinates based on what we just learned in this video. This is the end of part 1. See you again next time.